So today, we're going to talk about kernels and kernels. Now, the whole focus of this, the CALE, right? The apprentice workshop is for us to start someplace and go the distance. We're going to start at what is virtualization. We're not going to get into it really deep. We only have 90 minutes. But we're going to get into it so that we have a complete story from the beginning to the end. What I want to show you is I want to show you a kernel virtual machine. What is it? Good question. We're going to answer that. How does it hook up? What is this thing called QEMU? You're going to see presentations that talk about virtualization, and the nice guys from Zen were here a few minutes ago, and they mentioned QEMU in their presentation as well, but didn't elaborate. I'm going to elaborate a little bit of what it is and why we need it and what it does for us. We're going to talk about some products and some programs that we have, not really products, but they are programs that we have that are going to help us configure virtualization. But first I'm going to show you the easy way. Well, I'm going to show you how to do it with HTML, right? We've got to start somewhere. And we're not going to start with the GUI. We're going to start with a nice, easy HTML installation. Now, hopefully, how many people have Linux on their machine now? Awesome, because we can run KVM on your machine. Do you have KVM installed on your machines? Think so? Perfect. Because all the lab exercises that we have coming up, all the lab exercises make the assumption that we can run KVM. Now, for the folks that don't have it, KVM on their machine, I'll run through them and show you anyway. We might even get a volunteer to drive. You never know. But the whole series of exercises that we have start from very basic configuration. I wanted to address the condition. And one of the conditions is, here's the condition where somebody comes up to you and goes, here, take this VM and load it on this machine and make it go. And you look at it and you go, yeah, now what do I do with this file? Okay, we're going to answer that question. I'm going to show you some interesting ways to do that from the command line. Okay, so that's where we're going to go with this. But before we get started, let's get you the book. And the book is on some other location on my computer in a directory called home, ISO, class files. Before we get started, and through the magic of the computers, we have the odds and ends that we're looking for. What I'm actually looking for is this one. Ah, it didn't save it. All right, let's do it together. It didn't save my document, but that's what I get for doing it on my lap. Do you want to save the changes? I guess I got to cancel that thing out. Our virtual machines that we want to have. Don't save here, just go away. What I would like us to do to get the document now, if you've got other machines as well, shouldn't be a problem, should be pretty easy to do. What we want to do is we want to select a network. Now, we've normally been using this LF events, correct? That network will get you outside, and in fact, we may use it a little bit later. But do want to start off with one of these ALE networks, okay? Take your pick. AL1, AL2, or AL5, it doesn't matter. And connect to it. It's going to ask you for the password, and it's the same password as on your badge, right? Don't do that, it makes the thing go crazy. It's the password is Linux 1991. And it should connect up. And I got connected. I'm going to check my network. My network says AL1. So I've hooked up to AL1. And then we're going to open up a URL where you can actually get the documents. And HTTP, told you I couldn't type, 192.168.7.10. 192.168.7.10 should, we may need a backslash on that depending on that little server, take you here. Okay, did everybody get that? You got the documentation there? Awesome, awesome, awesome. In that directory are all of the CALE presentations, correct? Awesome. Ours is called Kernels and Kernels. And we have the slides. The slides are the same as the book, except they don't have the notes on the bottom. Because you don't have them in front of you, I'm going to actually use the notes so you can see various options that are in the bottom, and I can point them out for later, and you can get the PDF file and have fun with it, okay? Just so that everybody gets to see the stuff. So the big one, Kernels and Kernels PDF, is actually the document that we want. Just before we go there, there's a file called KNK Resources, and it's a whomping 85 megabytes long, okay? That's the smallest I could get an installable ISO Linux copy, and remember I said we're just going to give you a virtual machine and say make it go? There's one of those in there too. Okay, so I got all that stuffed in 85 megabytes. I wanted to focus on the mechanics of KVM, not how to install Debian or Ubuntu or Fedora. I didn't want to get into that, right? Everybody sat and watched an install run, right? It's very exciting watching 2,712 files install, and you can sit there and count them, but I don't really want to do that today. Make sure you grab that file if you want to follow along with the exercises. That's got all of the resources in it that you're going to need for the exercises, okay? And it is referenced in the documentation. I'm going to open up my PDF file, and I'm going to download it locally to my machine, save file. And it just saved it someplace. I'll probably never find it again, but that's okay. Actually, let's go find it. It will be in the downloads directory. So I'm going to go, oops, your download will be canceled. It's not done yet? Don't exit. All downloads complete. Go ahead and download the tar file. I don't particularly need it because I have it, okay? But I'm going to get you to download it as well. So I'm going to close out the HTTP session, go back over to my user-friendly file box, open up my downloads, and bring up my document that I'm going to use. Funny, it looks just like it's supposed to. Now, I'm going to make this bigger, because we're going to talk for a little bit. And through the magic of what happened to the first chapter? Chapter 1. Huh. I lost page 1 on that transaction somehow. Oh, no I didn't. There's page 1. What I need to turn off is the scrolly thingy. I'm going to turn off contiguous. And I think that that will allow this thing. Nope. This is not working today. Okay, don't worry. Well, you know, some days. I guess it wants this on. Okay, we're going to scroll. Okay, here we go. We saw this page already. Let's get on with life, the universe, and everything. Please notice we do have our Cloud Container Copyright Apprentice copyrighted, so it's available for all you folks to use. Remember what I said. This is what we're going to head off to. We'll talk about KVM, so kernels within kernels. We'll talk about KVM. We're going to talk about something called LiveBert. LiveBert is pervasive across all of the different distributions. So everybody's using this thing. So we'll talk about it. Makes your life easier. It will also make other hypervisors a lot easier to handle too. So this is a really good place to have that. We're also going to talk about a thing called virsh or virshell. If you came in early, you saw me using this command already, making machines go away and destroy them. This command is your friend. This is one of the really cool commands that we do get within the virtual environment. We have Virt Manager. Anybody know Virt Manager? No? That's the graphical user interface that we have. We're going to leave it for last. Yeah, shucks. We're going to leave it for last. I want to do as much as we can with the command line so we get to see what's happening a little clearer. And the interesting part is that when we get done, we're going to open up Virt Manager and go look at it with the GUI. And in fact, there's even a challenge exercise at the end of this to do all the labs over again within the GUI. Okay? But that's a challenge that I'm, depending on how much time we have, and I know the line between you folks and consuming adult beverages with fish, because that's after the session, right? Okay. All right, let's carry on. So, here's my title blocks. Did you guys get the file, by the way? Okay, no problem? Excellent. Okay, so we look at this and go, this is an introduction. When we start to think about virtualization, we talk about kernels within kernels, we're generally looking at running another operating system. And why would I want to run another operating system? There's one inside the box. Well, you might need to run it for a bunch of different reasons. You may have, I don't know, resource requirements where you want to have more operating systems on less boxes. That's a good reason. You may have a piece of brand new, shiny iron, nice new computer that old operating system doesn't run on. It can't recognize the processor. So you might want to take an old operating system and make it a virtual machine and then run it as a little virtual machine. Everybody's got one of those, right? I have a scuba diving dive computer that it needs Windows XP to download its data. Okay? So I have a virtual machine that has Windows XP and a single program. Is it which one?
Subsurface.
No, Subsurface is a Linux application. It runs on Linux. Oh, it works with lots of them. Oh, yes. I have a 10-year-old Citizen watch. The question is, what kind of dive computer do I have? And it's a 10-year-old Citizen watch that has a great little logging feature in it. And it's a very old specific, and they've never changed the software since I bought it 10 years ago. We'll talk scuba diving later, okay? Do I tell them now I'm a dive instructor? No. Sorry. But that's just an example, right? Where you have an old application that you need to keep running. Right? So you have this old application. So what we could do is virtualize it, and away we go. Another option we might get into, not necessarily in this slide, but you might get into a different architecture. What happens if somebody comes along and says, I want your application to run on ARM? And you go, I don't have an ARM. I don't have an ARM operating system. How am I going to deal with that? Well, through virtualization and emulation, these two run hand in hand, I can emulate the ARM and still run all of the ARM software on top of my on top of virtualization, on top of Linux, on top of my Intel set. So I can run it on top of all of these things, right? So whatever the reason, there's lots of reasons to do this, so whichever one you're looking at, let's go have some fun. The kernel virtual machine, KVM, as we mentioned here, it's an open source virtualization built into Linux, okay? It is not added on. It is in the kernel. It is compiled in the kernel. There's actually some kernel modules we'll talk to in a minute, okay? And it's been around since kernel version 2.6. Do you folks remember kernel version 2.6? Yeah, okay, good. Anybody remember kernel version 0? Question?
Yeah, what was the decision behind releasing the kernel as opposed to making userland and providing APIs?
I'm going to watch where I'm going, getting in front of the speaker. Excuse me. Yes, okay. I'm not part of the development team, okay? So I don't know what the decision was made for that. One of the things that we need it to do is it has to intercept certain calls from the guest operating system, has to intercept them and hide them or change them and make them real calls to the underlying operating system. Can't do that in user land. You don't want to do that in user land, because if it is in user land, somebody could look at that material somehow, right? You could get to that memory and see it. You want this to be as small, as tight, and as secure as absolutely possible. So that's why you would want it in the kernel. Okay? Does that answer your question? After a fashion. But no, I don't belong to the development team. The people that wrote it always built it as part of the kernel. Okay? Yep. Thank you. Okay. So because it's right in the kernel, KVM can actually use the kernel. So the kernel and KVM kind of work together. As I mentioned, when the requests come from the guest operating system. Think of this. You're going to sit down tomorrow and build yourself a hypervisor, right? You're going to run an operating system as an application. Okay? What are you going to do with memory calls? First thing, because when you run an operating system, it assumes it's got hardware. So it's going to say, hardware, give me memory, right? I'm going to manage the page tables. Well, you're now doing that as an application. Your application just said, hardware, give me a page table. And it's like, oh, hang on a minute. You as an application can't say that. Only the kernel can do that. So I'm going to have to intercept your call. I'll go do it for you. And I'll give you the answer back. And then I'll let you continue again. And literally, that's what KVM does with the kernel. Intercepts the calls that can't be done, does them for the guest, and releases the guest again. Okay? So as you can see, something like memory management. We get to use Linux's memory manager. We get to use the scheduler, the process scheduler, because your application is a process. Your virtual CPU is a thread. That's it. Okay? We can use the entire I/O subsystem. Now, this is kind of interesting. With kernel virtual machine, we're using Linux's I/O subsystem. So anything you can plug into a Linux box, theoretically, you should be able to see in your virtual machine. You might want to change it a little bit. If you've got a network card, you have a physical one, right? Now, I want to have physical network access from my virtual machine, from my guest. So I'm going to need some kind of a connector to hook these things together. Well, I could emulate the real hardware. So I could have a real 100 megabyte NIC card, then I would have to emulate it as a real 100 megabit NIC card. It has to be real. Or we can decide and use some features of KVM and the kernel and say, let's make a pretend NIC card. Let's call it a virtual NIC card. And I'm going to connect from your host down to the hypervisor, down to the hardware, right? Down to that operating system that's running as the hypervisor. I'll create a virtual NIC card. Do I have any rules on how fast that can go? There's no wire. There's no fiber. There's no electronics. It's just a piece of software. It can go as fast as possible. Okay? I just lost my screen. It can go as fast as possible. So I can use these virtual devices and hook them all together. Okay? So not only can I use all the things that we're already testing, running, I don't have to run a second one. Because when I run a virtual machine, right, it's going to have memory management. So anything that that virtual machine asks for, we're just going to have to look at it and say, yeah, hang on, we'll go do it and come back again. Because we don't want two things managing memory at the same time. Bad idea. In order for this to work, we need some specific enhancements to the basic Intel chipset. Okay? Prior to these things existing, this thing called VTX for Intel or AMD-V, known as VMX and SVM, without those two pieces of firmware, hardware inside the chip, this wouldn't work. Okay? Are these the only things that we have? Actually, no, there's more now, but these are mandatory. So if you would like to know if kernel virtual machine will work on your machine that's sitting in front of you, look in /proc CPU info and look for these two flags. And in fact, the command is right here. Okay? Type that in. It should come back with a big mess, because that means it's in there somewhere. If it doesn't come back with anything, just comes back with a user-friendly cursor prompt, nothing. You don't support it, okay? This is an old i5, Intel i5, and it supports it. Almost every machine we have recently will support KVM. Are they the only extensions? No, they're not. We have things called EPTs and SRIOVs and DDIOs, and I think we need to get some more alphabets, but extended page tables. Extended page tables allow us some liberties with the page table mechanism so that we don't have to do page lookups more than once. Depends on the chip. Single-rooted I/O virtualization. That's kind of a cool function where we can have multiple virtual machines talking to the same network card or portions thereof. So you might have a 5-port network card or a 4-port network card. I take this port, give it to you, and this port, give it to you, and this port, give it to you. And I use SRIOV to do that. So that's another cool thing. DataDirect Technology, yeah, I'd have to look that one up. It's one of the ones that I don't get to the point of actually doing these. Do we need to code these? No. The device module, the kernel driver, needs to talk to these things, okay? But when you're buying a CPU, so you're going to the Intel store to buy a new CPU, and you've got one that's $1 and one that's $10. And you go, what's the difference? They're both, whatever, i6s, same speed, same everything that I look at. Why is one more expensive than the other? Look at the option list and see if it supports a bunch more options, right? Because the hardware manufacturers have different option sets in different chips. And that number on the end, i7-8550, will look that up and it will tell you what it supports. Because you could look at an i5 on this and an i5 on that, and they could have different CPU chips in them. If you would like some very interesting rating, cool, then have a look at some of these things. I picked AMD and Intel and ARM, and these are links that will take you to discussions about the various options that are in those architectures. Cool. Now, I mentioned earlier about there's a kernel module. Well, actually, there's two. Well, if you really want to get down to it, there's three. There's one called KVM-K0, or KVM-KO, sorry, 0. And it's common to all architectures. Then what does it do primarily? Well, it's an interface, but the other thing it does is besides interfacing with the KVM API, is it gets the other module, right? It gets the KVM Intel or the KVM AMD module and gets it loaded as well, okay? That's what those guys do. So that's what they are, two modules. They do, KVM-KO does take command line arguments, so you can change its behavior as well. Now, the API interface, KVM, uses a thing called IOCTLs, or IO controls. And these IO controls are the actual conversation that you have from program language to make a virtual machine. Now, when we ask it to make a virtual machine, it's just an IOCTL, and the system goes, yeah, okay, it did that. And what did it do? Well, not a whole lot. It made a process table and stopped. And then you've got to say, okay, now if I got to do get some memory, and give it to the virtual machine, and get some of this, and give it to the virtual machine, and you build up that process so that it actually functions. But if you want to see the barest, absolute barest virtualization you can do, here's an awesome reference. Here. LWNet articles, and this is an actual example of coding the KVM API directly. And it links out to an MIT program, okay? Do we want to do this? This is an assembler. Assembler programmers? Awesome. You can keep you busy for the next couple of days, and you can do one of these things. Actually, I want one before we go home. Anyway, you could do this. It's here. Why do I bring it up if I'm looking at it going, well, this is crazy. Why would I want to program this stuff in assembler? The point is, we have the KVM API allows us to manipulate the memory, create virtual machines, virtual CPUs, right? And we use VMIO controls to create a machine. That's it. The API is documented in the kernel. It's in the kernel doc. And of course, we do have an example of it. So that you get an appreciation as to how low of a level creating a virtual machine is inside the kernel. Are you going to do it? Me? No. Do I like reading about it? It's actually a very interesting read. It's a good article. So, if you wanted to get your C programmer out, yes? That one? Hmm? The bottom one? What network are you on? If you're on an ALE network, you cannot get to it. Let me switch to the network. 1-1. Did it come up? Okay. Yeah, it's 1-1 at the end. And mine's still coming online. All right, good. Awesome. Thank you for checking. I do my best to check every URL I put in here. Yes. Nothing else exciting. So, oh no, we went past it. So that's how we get to virtualization. That's a little bit on virtualization. Oh no, here we go. And I missed my page up. I apologize for that. Look at all these cool things. There we go. Oh. The modules. Here we go. QEMU. I call it the glue. And people go, what? You can't call it glue. Oh yeah, I can. QEMU stands for Quick Emulator. And Quick Emulator's been around for a long time. I could probably tell you when, but it was a long time ago. Suffice to say, we were running QEMU on 286 machines. Okay, so there was no, okay, and 386 machines. So we were running it really, really early. And its whole point in life was to emulate things. It can emulate CPUs, like emulate an ARM. It uses a instruction translation. As the instructions execute, they get dropped down to an instruction translation layer. They get translated into your current machine. Mine would be Intel, and then drop down and continue. Okay? So the whole idea of an emulator is like a bash shell, right? You type in text, It goes into the shell munches it around, turns it back into some reasonable code to execute, and executes that code, right? Same kind of thing, same principle that you have foreign code, translate it, run it, okay? So this is kind of neat. It emulated a bunch of CPUs, and in fact, it's still used today for exactly that reason, because I can emulate stuff with it. Something that's brand new, the hardware doesn't exist yet, but I have the specifications. I can program the emulator. I can get my code going. It has a whole list, well, a little list, of device models. So it had to say, what's a disk drive? Remember I said about that virtual network adapter we should use? That's where it came from. Why should we rewrite it? There's already one in here. So we can use his virtual network adapter. We can use his virtual disk persona or view, right? He knows what a virtual disk is. He knows how to format it. He's got a tool. Let's just use his. Let's take these tools and exploit them. Well, it is a virtual machine monitor or a hypervisor. It's what it is. But it also has another cool thing. Besides using a dynamic binary translation, it can use the virtualized extensions when coupled with KVM. In QEMU speak, it's an accelerator. So anything that, if while I'm thinking about translating stuff through my binary translation, if I come across something like a memory feature, I can just hand it off to KVM, done. I don't have to have memory mechanisms built into QEMU. So I cannot execute chunks of code. So therefore, I get to run faster. So QEMU is the glue. It's got CPU models. It's got device models. It is a hardware virtualization when coupled accelerator for QEMU. With QEMU and KVM, you can achieve near hardware speed, near native hardware speed. Are you ever going to get it to 100%? No. Are you going to get it close? This gets it close, right? So now, we don't do a whole lot with Mr. QEMU. I did want to make sure that we had a look at it, because I'm going to put it in a picture in a minute. There is reference documentation for QEMU at the bottom of that page. Did I push a button? No, I didn't. Here we go. Sorry, my fingers are off today. Yeah, we did that guy. Here we go. There we go. QEMU, by the way, is its own separate project. Okay? So we have a couple places you can have a look at documentation for it. Okay? And if you want to understand its devices, there's a nice device list in here. Okay? And you can see all the various devices. And that list has grown over the years too. Okay? So the list is cool. So this is how we glue it together. Now, push the right button this time. We have a picture. And what I wanted to do here was to try to put all these bits and pieces into perspective. Because when I fire the machine up and say, run a virtual machine, what happens? Okay, so start at the top, start at the bottom. Go up the top. I have my virtual guest. Okay, this is the operating system that is running as an application. It has applications, and it has its own guest kernel. And the guest kernel is awesome, right? It's whatever it is, don't care. And then I plugged in a virtual NIC card and a virtual disk that uses QEMU emulation. The other side of the QEMU emulation talks to the kernel module and talks to the block devices, which talks to the hardware. So not only does it do this little bit here from the guest to QEMU to provide that facility, it hooks into the kernel knows how to talk to block devices, and it goes out to the disk drive. How much performance impact do we have? Not very much. It's very stingy on its CPU utilization. These are very, very small pieces of code. even when it comes to I/O. Yep. Sorry? Here, use this. That way everybody can hear. Sorry?
So how much of a percentage you're going to lose?
How much of a percentage? That's a real big variable because it depends on what you're doing. I do not have an answer for you. Okay? As I said, we're trying to achieve nearly hardware speeds. What's the difference between running it through QEMU and then running a raw device? You would have to experiment with your hardware to find out which one is going to be best for you. If there was a single answer, I would definitely love to give it to you. But it is a very variable question. Because I could take a whole PCI adapter and pass it right through to my virtual guest. I can do that. Do I want to do that? I don't know. Do I want to have this virtual machine have the ability to move it to another piece of hardware? Do I want to be able to migrate it? Well, if I have hardware passed all the way through, I can't migrate it. Darn, okay? Would I get a better performance? It'd be close. I'd love to try. On the tests that I have done with my i7 processors using solid-state disk drives, SSD disk drives, I can't measure it. Okay? Now, is it because I've got i7s with SSDs? Don't know. Need to find something slower to try it on. Okay? So that would make the problem worse. Okay? Thank you. Thank you. One of the other things we put up here is that we put our virtual CPUs drop into KVM KO. Now, the virtual CPUs drop into here and become processes or threads. That's it. What can I do with a process or a thread? Well, one thing is I can pin it on a physical CPU, right? I can do that. I can restrict how much real CPU that virtual CPU is going to get. In newer versions of the kernel, I can actually say that process gets 80%, gets no more than 80% of one CPU, ever. Okay? So I can do that. Or I can use a weighted mechanism. But the point being, these things, which we think are CPUs, are actual just processes running on our machine over here. Okay? So we're still looking on the lean side. We're not getting too much stuff in the way. Virtual memory goes the same way. We've talked about virtual memory. So we have all the combination of these components that we plug together, and this is what we refer to as KVM. So it's a lot more than just the one little bit and piece. So we've got all this kind of stuff, right? Configuration method, configuration method, that KVM API. We're going to need something to talk to that because we don't want to get into that low level. We want to be a little higher than the low level. We're going to need something to boot it. Ever thought of the BIOS? When you have an operating system, right, you normally have a piece of hardware and you have a BIOS, and your BIOS starts, picks a disk drive, and runs. Where do you expect we're going to get that from? Any ideas? QEMU. Yeah.
QEMU can use just an image file of a given dial, for example, right?
Can QEMU use an image file of a drive?
Of a BIOS.
It,
At least in the past, it was possible.
It still is possible. You can change the BIOS. You can get, there's a whole selection of them with the commands that we have. You can select which BIOS to use or not use. Just boot it direct if you really want. Okay, thank you. Where are we at? Device drivers. Oh, didn't talk about monitor. Didn't talk about monitor. Monitor. What the heck's a monitor? The QEMU monitor lets us look at QEMU, and therefore the call is going to KVM while it's running. So we can open up the monitor and we can interrogate what is it doing. So we can get a bunch of disk I/O, and then we can say, okay, I want you to show me all the QCOW commands that you just executed, and you can actually trace them live. Now, you want to do that, you have to come to my other class, okay? Well, it was a little too much for today. However, we can use the QEMU monitor to actually see what's going on, debug it, check it, trace it, watch things go by. Awesome. KVM does all the heavy lifting. How are we going to configure this thing? All right. We need to get into some of the configuration things. We can do it on the command line. Okay? What do we have to do to make this thing work? We need to confirm or load an appropriate KVM module. Is KVM running on the machine? Yes? QEMU hooks into the kernel as a hardware emulator.
It runs in user level?
No, it's system code.
Is it built into the kernel, or does it have hooks to register itself?
It's compiled in the kernel. It's not an external module that we load and unload.
Okay.
Okay? It is compiled in. All we can do is turn it on and turn it off.
So if you needed to write a custom emulation for a hardware, you have to get it compiled into your own kernel?
Correct.
Okay.
So if you wanted to change, because there's a list of things that it will emulate,
Okay.
and you'd have to get it compiled in.
So it's
Now-
not configuration driven? There's no option for that?
Well, QEMU has a different list of what it can emulate, because the emulation comes from QEMU, right? KVM is just doing hardware acceleration of the management of the memory and the scheduler and the processes, right? So it's just doing that management part of it, not the emulation. QEMU is doing the emulation for you.
Okay.
Okay? Help? Thank you.
Yeah, I was just confused if it was injected into KVM or if it's built with the kernel and KVM.
Yeah, no, KVM just, the way that I think about it is you look at the KVM kernel module itself, and what it's doing is fixing all the address translation to keep them separate. It's also the interface to the hardware. So if you have the hardware with some fancy new Intel super duper virtualization option in the chip, the only place that needs to be coded is in the KVM module itself, right? And the developers will pop that right in, and then we can access it through QEMU, no problem. Okay? Excellent, excellent, thank you. Okay, so to get this thing going, we need to make sure the KVM is running on a machine. We'll see that in a minute. You need to have some kind of an image file. Well, we said earlier that somebody just came along and gave you an image file and said, here, make this go. We don't even know what's on it yet. And yeah, I have one that you don't know what's on it yet. Okay. So we can start QEMU-KVM or similar name, okay? Different distributions have a different name for this thing. But it's basically QEMU-KVM something or other, and you pass it a list of options, okay? And the list of options is about, oh, this big. It's a big one. But we need to describe the image used for storage, the possibility of a CD-ROM, what kind of memory size are we going to assign to the thing, some kind of a boot command. We need to specify all this, the QEMU-KVM. When it first comes up, we can install. We can install to a pre-created image file or raw file. And then once it's finished, we can stop it and reboot it, and our operating system should come up. Okay? That's what we need to make it go. So, what would that look like? Well, there we go. QEMU image create. I'm going to create an image suitable for a disk. So create, and the type, the -F, QCOW2, copy on write. Simply, it just doesn't allocate the whole disk. It just allocates a little bit of it, and it'll grow to that size. And it's going to be called vdisk image. And the size, 8 gig. If I want to boot it, and notice the name changed. I want to boot from my CD-ROM, QEMU-system-x86-64-HDA, first disk. Vdisk image, that's the name of the disk. That's the name of the CD-ROM. Boot from D. Boot from D? Yeah, okay, so we inherited some old things saying C is the first hard disk and D is the other hard disk. Okay. Ooh, well. Memory, 512. That'll work. That'll bring it up. Awesome. When we're all done, we can bring it up without the CD-ROM, and it will work. These commands do function. Now, all that's fun, but we need help, okay? I don't want to be doing these really big, long commands. So what we're going to do is we're going to get ourselves another project, a project called LiveBert. Now, it is an open source management tool for managing a bunch of virtualization platforms, not just KVM. It will manage other ones. We'll see in a moment. Project homepage is there. Let's see what it does. Here's LiveBert. LiveBert comes in two parts. There's a libvirtd daemon that runs around in the background, and it does stuff for us. It talks to the APIs, okay? And it talks to the various virtualization environments. We'll get around to that in a minute. It also has an API interface that we can use, okay? Programs that exploit that API interface, a command like virsh or virshL, right? That command uses the LiveBert API to manage, oh yeah, look, Xen, KVM, LXC, OpenVZ, ESX, and the list goes on. You can manage all of these kind of products with the same API. So I can walk up to my Xen box and go virsh start machine name, and it'll come up. I can walk up to my KVM machine and say virsh start machine name, and it'll come up. The nice thing about this, as these things change and improve, libvirtd takes care of it, and the API interface stays the same. Over my history working with virtualization, Xen has changed a couple of times. They've changed their command. It used to be different than it is today, and virsh takes care of it. Don't matter. That's one of the main guys. That is our text command line interface that is the Swiss Army knife for configuring, managing, and viewing virtual machines. The graphical friend from the same project. By the way, virsh and Virt Manager are part of the LiveBert project. In fact, there's a few other ones that you could look up. Virt Manager, the graphic guy. Okay, we'll see it in a few minutes. Other projects, there's a thing called overt. If you don't like this, there's a thing called overt that you can install and run. It has a web front end, and there's more. This is not the end of the list. Okay? These are just the ones we wanted to focus on today. So I've got two things. I have management environments, and I have virtualization environments, and libvirtd takes care of it for us. Well, obviously, this thing has got to run around in the background. Well, not obvious, but it ends in D, so usually it's a daemon. Here we go. Server-side daemon runs on the host servers, and it performs management tasks with the guest. Start, stop, migrate, networking. Okay? And the API interface gives us a way to talk to it. Okay, perfect. Kernel, KVM, all these guys. The daemon itself, if we look at it, and it needed to have another quick look here, it has various hypervisor drivers. It has various storage drivers, right? So I can use something like Gluster as my storage for my virtual machine. No problem. Also has node drivers. Remember we saw the SR-IOV adapter earlier? We said, yeah, we could use that. Well, my good buddy libvirtd is going to help us out with that. Okay? So there's many, many devices that libvirtd will handle for us. So why am I showing us this? Because all of this very cool hardware and low-level things are going to be available through the LiveBert API to make our life a little easier. Oh, VM start is the same. Toolkit. Hey, look at that. All this wonderful stuff. The API overview looks very similar. Now, I put a couple of extra things in here because definitely worth having a look at. They all say and more. Okay. Virt P to V, physical to virtual. We got a program that's going to help you out. It's going to take your physical machine and turn it into a virtual machine for you. Awesome. Or virtual something else to this virtual. I'm going to switch them around. Here's some of the command line tools. Remember I said there was more? Virsh, there's virt install. That is, you're going to see that. That's awesome. Virt clone, virt image, virt what? STAP. All of these command line tools we can use. There's a few libraries for the library folk that are writing code. There is infrastructure as a service that locks in or logs into LiveBert API and talks to it. Little things like OpenStack use LiveBert API. And if you like, there's other applications of Kimchi, Overt, Mist, VM Manager, etc. It's not a single place, right? If you don't like the ones that come in the box, change the interface. Why not? Okay. Awesome ways we can use LiveBert. Cool. Ah, yes, all that wonderful stuff. Now, I said virshL is your Swiss Army knife. And it really, truly is the main interface to LiveBert. And as we've seen, LiveBert looks like it can do a lot of stuff for us. One of the things that LiveBert does for us, it keeps the configurations organized in specific directories. So it knows where they are, okay? So it's good. What other things does it manage? These things. This is a short list. Guest, right? Guest domains or virtual machines. It manages the virtual machine, the devices, the virtual networks. Now, one of the cool things that we have about LiveBert, when you install LiveBert and boot your box, one of the first things that it does on 3 out of 4 distributions is it creates a default network that hooks you up through a NAT. So when you install any virtual machine, by default, you get a network adapter that works. You don't have to configure it. You just have to start the machine. And I said 3 out of 4 distributions, I'll take that. A virtual interface. Yeah. We can get a console. We can get a text-based console. QEMU will let you do that. You can get a TTY one. It's got one called virtViewer. Goes with it. A virtViewer, it's an awesome. Well, I was going to say terminal, but it's a GUI terminal, but it just works. You're going to see this. You're going to love it. Way better. I use it. We used to use the console all the time, right? Text-based console because we're text-based console guys, right? This is just too easy, and LiveBert works. Okay. This command, way too many options. Okay, it's got way too many options, but don't take any away because they all work. LiveBert.org virsh command ref is a great place. You can also do man page on it, or you can actually enter into a shell. Just type in virsh and press enter, and it'll drop you into a virshL shell, right? So that's a good way to go. Right, and remember, supports all these other different environments too. Now, let's get started. All right, let's get something going here. We need to get our first VM. We're going to use a pre-existing disk. Somebody came along and gave us something and said, here, start this VM. We know nothing about it, other than it ends in VMDK. So we need a few things, and we're going to use our short XML file. I don't know why it says HTML in the middle of it. It's an XML file, doesn't matter. It's an XML file that we're going to use, and it needs a few things. It needs to know the name, right? That's basically its index. It needs to know how much memory it gets. It needs to know the memory. What architecture do you want me to have? Oh, 64-bit. Which hypervisor am I going to use? What am I going to boot from? And what devices do I need for an emulator, for a disk, for a console? And am I going to use graphics? Locally on the machine, I would use virtViewer, and I would use virtManager. I can use VNC, which enables what? remote connection from almost anything as the graphic console. Okay? Vert Viewer could do remote too, but we're not going to do that today. And something I run when we get there. So this is what we're going to do. You guys ready for a very tiny little XML? Who wants to type it in? All right, okay. I promise this is the only time we're going to actually see this, I think. No, actually see it again. But let's point out the things that we just looked at. The name, right? The type, KVM. The type architecture is PC, hardware virtual machine. What's my emulator? QEMU KVM. QEMU KVM, and that's going to make sure that we use the extensions for KVM. Here's my disk, right? The type. It's a file, disk, the name is QEMU, it's a QCOW2, and here's the image, varlib, LiveBert images, blue.image. And it's a VDA device, and it's sitting on busvert.io. Perfect. The other guys are the terminals. Here's my serial TTY terminal. And this is a VNC going into port 1. Okay? So that's what we've got. It does work, by the way. That does work. Was that fun? Now, that's kind of like the minimum. I could probably get rid of some of the stuff, like on crash, get rid of a couple things, and I could probably make it shorter. But once we register this with our good friend LiveBert through virshL, it's going to go from this tiny size to about this big because it's going to fill in all the defaults that the system has. You'll experience that in the lab exercise. How do we get it to register? We use a command called define. We've got our XML file, right? So we're going to say virsh define. And we define the virtual machine based on the XML file. That's it. Boom. Okay. What would that look like? All right, that would look like this. Okay, this is oh, so darn. You want to check for typing mistakes in your XML file? Virt validate, virt-xml-validate will validate to make sure you've got probably a working machine. Comes back and says validates. This registers it. Virsh, define, domain name. That's just whatever the machine's called. That registers it with LiveBert. We're good to go. Okay, because as soon as we got it done, right, here we did, our example is blue. We said virsh list, but I want to see inactive virtual machines as well as active ones. So I say -- all. And I have Alice and Blue and Bob. And they're all shut off. And we just defined Blue. So, easy to control. Now, where does LiveBert put, or virshL and LiveBert put the stuff? Well, I'll tell you. The resultant configuration file lives in ECC, LiveBert, QEMU, name, XML subdirectory. And it puts a configuration file there. You go, well, can I edit it? No, please don't. What's it there for? When libvirtd daemon wakes up and the LiveBert API is used, it needs to know how to go look for machines. It needs those configuration files to find your machines. If you did that QEMU command I said that was really, really long earlier, LiveBert will never find it. It needs that configuration file in that directory. So, if you would like to see the configuration files, display them, have a look. There's also network one as well. Have a look. Don't edit them. You're just going to break it, okay? You know, everybody, well, I can edit it. Yeah, okay, don't edit, you're going to break it. There's an easier command, by the way. If you want to edit one of these files, there's a virsh space edit domain name that'll bring it up in a VI editor. And you can do anything you want to it then, because when you close it, it validates it. If you pass validation, it writes it into that location. If it doesn't pass validation, all those changes you typed in, bye-bye. The virtual machine still runs, though. Okay, that's why. So that's what it's for. So the library, etc LiveBert library, that's where a lot of our stuff lives. That's where a lot of the KVM stuff lives. Here's an example. My little file. Remember our blue? Okay, so in domain new defined, var lib libvirt blue XML, that's where we started. He was 695 bytes long, right? We did a define, which caused him to be imported. We look in etc libvirt QEMU blue XML, and we find out that he changed from 695 bytes to 1907. None of which we did. Okay? It just filled in some defaults. Okay? And if you'd like to go see them, check the differences, see what it filled in, awesome. Don't change it. If you want to start and stop a virtual machine, virsh can do this for us. Start. Shut down. There you go. Virtual machines, okay? Normally, if the virtual machine is in a good mood and that client is running, you can issue it an APC shutdown command and it'll shut down, right? And about 90% of the time it looks at you and goes, forget it. So this is the nice way to shut your machine down. This is pulling the plug, right? Just like on your computers, it's like walking up and going and pulling the plug. Yes?
Why is it called domain?
Why is it called domain? Good question. Deserves an excellent answer. In the early years, and I believe it was then, I'm not sure, they call them domains and still do. Okay? Some people call them virtual machines, right? But the domain or the guest or the VM name are all the same thing, okay? But it's a hangover from history. Excellent.
Domain implies that there's multiple things under the domain. That's why I'm asking. So is that possible?
Virtualization within virtualization? Yes. Are we going to do that this week? No. Okay. Are we going to do it next time? I want to. We'll see. We'll see. But, yes, thank you. Yeah, I could say we should make it all consistent, but the other thing is good, and I'm glad you brought that up, is that the documentation you read some of it off the net, out of man pages, out of wherever, you're going to see it referred to as VM, VM name, domain, or guest. Right? You'll see it called all of these things. So be prepared. Be prepared. Okay? Thank you. Now, what else can we do with this thing? Start. Okay, we can start it. Good. Yeah, we didn't have start on there, but we're getting pretty implied. Dash, I joined it. Console can be appended, and you can actually get a text console at boot time. So if you really, really want to see the grub thing boot up, put a console on it. Does the console stay active? Nah. We're going to use Spice or VNC, the Virt viewer. We're going to use the Virt viewer or VNC. It's just way easier. Okay? But you can use it. Yes? Correct. The question says, virsh destroy domain doesn't actually get rid of the configuration. No, it does not. It's just, that's their command for pull the plug out. So if we call it shutdown, that implies graceful. If we call it halt, halt calls shutdown. So it wound up being called destroy. Okay? I know, the first time you type it in, you're like, yeah, destroy. Excellent. Okay, I gotta hurry up. Text mode, console mode, we talked to these things. Okay, text mode. We can do this with the dash console. When we start, we get a console. You can do it standalone, virsh console, machine name. Or we can use VNC or Spice for the display and use virtviewer, which I highly, highly recommend. Okay, we'll see this in a few minutes. If you want it to go away, undefined, gone. Okay, it just goes away. Dash dash, remove all storage. Yeah, okay, anything hooked to that VM is gone. Go gently. Virt Manager, graphical interface, does everything. Virt Viewer, graphical interface for connecting to the VMs. Virt Install is a command line driven installer. That is Virt Manager. This is Virt Manager looking at a machine. The machine is called test 1, and I've got, oh, I can't even read it. You can't read it either, can you? OS emulation, performance, CPUs, memory, boot options, disk 1, NIC card. Can't read it, can't keyboard. Anyway, all the pieces that are available. Remember I said you get a lot of defaults filled in when you bring in the config file? Well, that's all the defaults. Can you edit them? Yes, in the little boxes. Highlight them and the little boxes pop open and you can change things. Virt Install is one of my favorites. It's an application that uses a LiveBert interface, command line, and you can have a text or graphics installer pop open. Either one, don't care. Okay? It has an option, and this is where we're heading to. Import only. Remember that disk that somebody gave you? We can give it about 4 parameters, and one of them being the name of the disk or the name of the file, and say import. And it will import it and create a virtual machine without touching the contents of that disk. Awesome. virtmanager.org, lots of cool things. Okay, so here we go. Less stuff this time. We're going to pass name, memory, storage, disk or file system, and some install option. And here is this sample. So I'll just read it real quick because it's short. Sample using virt install to install Debian from DVD1. If you download DVD1, a Debian, this works. The minimum disk seems to be about 1.5 gig. If I make it smaller than that, the installation fails. Okay? I was trying to make a small disk for you guys. So, or you folks, I'm sorry. Careful of the install. It may connect to outside resources. So before you do this install, shut your Wi-Fi off because the Debian install will pause for a second looking for repositories and then give up and carry on. Or if you leave it connected to the network, it will go to Debian. Your choice. Here's what it looks like. Here's virt install. All this means is continuation characters because it's one big long command. And it's just basically name, memory, disk size, how many vCPUs, what OS type is Linux, OS variant, and there's a list, Debian 9, graphics, none, use boot, use serial, yes. So no graphics, and I have a serial console. Perfect. CD-ROM is a file, press the button, up it comes. This will install Debian 9. Okay? The import option skips the install process. That's the really cool thing, because I can get a VM from somebody and just say import, right? So give it a name, give it some memory, tag the disk, kind of guess at what the disk type is. Oh, by the way, undefined or leave it out. And it goes, maybe if you gave us more information, I could go faster, but I'll run anyway. There is an option of generic, or just leave it out. Import. So how many lines? 1, 2, 3, 4. And it will work. I decided to put in the OS type in there. Here's one down here in the bottom that does another one. Okay? This time he used a disk. So here we go. So disk path, home, Lee, virt KVM, CentOS 7, .vmdk, bus IDE. Yep, that's your disk. And away it went. Did I have to convert it to a QCOW? Nope. Should I convert it to a QCOW? VMDKs are made by one of the other virtualization vendors. They work, we can read them, we can write to them, but the performance is not as good as QCOW2 when running with KVM. So if you just want to test it, great. Want to run it for a long time? Convert it into a QCOW, you'll be happier. Questions?
Can you pair KVM with QEMU user with the application level emulator? You can't. Or does it remain in software, the user application mode emulator?
You want to, I think the direction is, can I have a QEMU user environment dedicated to a single user?
No, with KVM extensions, with KVM acceleration.
If you don't mind, QEMU user, the whole idea behind it is there is no kernel hardware support. That's the whole idea. So it's entirely emulated. The line between QEMU and KVM is extremely blurry because essentially the KVM side is the hardware virtualization, the hardware acceleration portion of QEMU, and QEMU is the software emulation portion of KVM. So I mean, it's the same people working on both. So I mean, it's shades of gray from one end to the other. So KVM and QEMU are similar. It's just that if you get rid of KVM altogether, you're just left with QEMU, which essentially is the user space only side of things. But with KVM, it has to be on the Linux kernel. There's the whole point with KVM is that you're on Linux using the acceleration portion of the hardware, with QEMU being the front end, feeding the bits that it can be done in hardware through KVM. Yeah. KVM is essentially a driver to QEMU, like Lee said.
Yeah, but that's, you're wanting to run it on a Mac, right?
Yeah.
Oh, a PowerPC Mac. Oh, well, that even gets more exciting. That requires large quantities of adult beverages. Now, how are we doing for time?
We have 10 minutes left.
Okay.
So, if we can do a demo, that'd probably be the best way.
Well, let me at least explain all the lab exercises first, because what I would like you to do, and I've given you some really cool toys. Did you guys help download those stuff, right? That little tar file, that little resources file, it's got two really interesting little files in it. One of them is a VMDK. It's a virtual machine. It is a Linux, okay? Anybody know Tiny Linux? Tiny Core? It's a tiny core, okay? So why did I pick on tiny core? Why should we carry around gigabytes of stuff just so that we can watch the virtualization work, right? So we got rid of it, got the little tiny operating system. So it's about 25 meg. I took the tiny core middle version, right? Just the core Linux. I took it and I remastered it with the install program and made it an ISO. So that's the second file, is a customized tiny core ISO file. The nice thing about that one is you can use it to actually use virt install and run through the install process of a CD-ROM to a disk drive. Okay? You have to create the virtual disk. And the virtual disk size, 100 megabytes will be fine, right? See, a little tiny operating system that takes up little tiny space so that you can adjust and experiment with the various commands with virtualization, as opposed to trying to drag around an 8 gig image of whatever distribution, right? I just wanted to focus on those. To that end, let me run through these quickly. And I'm around if anybody wants to play with this stuff more, by the way. The first one, we want to make sure that your machine can run KVM. So we're going to hop down to the solution. We need to run this thing, right? And if it works, you should get lots of stuff. If you get nothing, it's not there. But you can actually go look in proc CPU info and go look at the flags and see if you can find one of those two flags. Okay? Get the resource file, right? You guys got it. These are the required packages if you haven't got them already, okay? This is for CentOS 7, OpenSUSE, or Ubuntu. Okay? And those all, it works for all of them, right? I did all of these things to make sure they all work. Once you get it downloaded, make sure that LiveBert is running. We're going to assume you're running systemctl. right? So you got system D. So system status, libvirtd. If it says stopped, start it. Right there. And make sure you enable it so it starts automatic later. Okay? And if you want to check the status, there's a status command. If you're using Ubuntu or CentOS, we have better luck with Xorg over Wayland. Your life will be better. Okay? Virt Viewer with Wayland, it's a little shaky. Much happier with Xorg. If you're using OpenSUSE, there are some specific instructions here. Anybody using OpenSUSE on their laptops? Darn. Okay. You may get challenged for the administrator password all the time, and you get this silly screen up that says, keep typing in your administrator password. Want to make that go away? Because we're going to be running the commands all the time. There's a configuration file in etc libvirt, libvirtd.conf is a configuration file. If you drop in Unix socket group equals libvirt, assuming you have a group called libvirt that everybody belongs to, you'll be able to run libvirt commands without being prompted for the administrator password. Okay? So, we're ready. Exercise 2. Get that virtual machine running. So we've got an image called tiny2 VMDK. I want a 1 CPU, 512 megabytes of memory. That's the disk, and I want to use virt viewer to talk to it. How many lines do I need? 5. 1, 2, 3, 4, 5. Anyway, here's the lines. Create the directory, untar the file. I'm copying it to a location, var lib libvirt images. Why? Because that's where my good friend LiveBert expects it to be. So I'm just going to make him happy. Put it there. I create my image file. By the way, and this is worth looking at too on your disk, on your files. Look at this. This is the same XML file, tiny2. But you'll notice, do a diff on it. You'll see what I had to change for Ubuntu, CentOS, and SUSE to make them work. I don't like having to have a configuration file that's that sensitive. But we'll get rid of that. Just in case you wanted it, this is what it is. Okay? You've got that in your disk. You've got it here. Do the define. You can do a dump XML command. That will dump out the XML of the running machine. Some list commands, some destroy commands. Create a virtual machine using virt install. We're going to create something called tiny3. 1 CPU, 512. You're going to use this disk as a virtual disk, and it's a copy of the previously used via tiny2. And I want to use a network called default, and I use virt viewer to make it go. Solution follows. Make sure the DMS mask is running. Do a virshell net. Yeah, okay. What this is all about is confirm or create DMS mask. Make sure that it's working, because if your network's not working, it's going to be ugly. And in fact, this is how you get the default network to work. Remember I said 3 out of 4 distributions have a default network? This fixes the 4th one. And you know which popular one it is? Come on, somebody guess. What do I need to do this for? No guesses? SUSE. OpenSUSE. They don't ship a default network. I got an appointment to talk to the guys about this, by the way. Okay. Enough of the user-friendly HTML or XML. Oh, by the way, right at the top, it shows you how to define a network, right? Can I edit this stuff? Sure, virsh edit. Anyway, don't do that. Here's my virt install. Away she goes. And I dumped them out and compared them, just for fun. Create a VM from a CD-ROM image. All right, here's the instructions to run through that CD-ROM image. And you do it, here's the install, right? Install tiny core memory CPU, CD-ROM is that thing. The disk is going to be tiny core QCOW2 size 0.1. So we're going to let virt install create the image for us. That's a tedious line we don't need to do. Just let it do it. Type Linux, variant generic. It's tiny core, it's generic. Boot, use serial, up you go. And Then you can install it to the hard drive. This is, by the way, the instructions to install TinyCore onto your hard drive image. Boot. Here we go. I did this, and I have the instructions for it, and thought there's no way we're going to do a download of 3.8 gigabytes of stuff to make this work. But I thought, well, I'll take it out. And I thought, no, I'm going to leave it. That works. If you want to try it, it'll work. Okay? And this will allow you to install a very text-based Debian operating system from that DVD. Okay? Just download it and go. It's a blast. And the last exercise is use Virt Manager and do it all again. Use Virt Manager to go explore what you've already done with the command line. Go look at it. Fiddle the numbers. Give something 4 CPUs. See what it does. Give it 4 CPUs and go check the processes. See how many processes you have. See what CPUs they're running in. Experiment with it. With these tiny little machines, it's an awesome experiment. Any questions? I would like to thank all of you for your attention. Hopefully this is useful and at least entertaining.